Hey guys, welcome back to my new video. In this video we will be learning about a package in Python which is known as NumPy. So NumPy generally refers to numerical Python. As it specifies in the name, it is used to solve complex numerical operations and also problems which are related to matrices and arrays. So what is NumPy? NumPy is a numerical library which provides multi-dimensional array objects and functions. Like we know that there is not a specified name called as an array in Python. Instead of that we use lists, tuples and other data structures to store different values of same data type or different data types under a single variable name. Here NumPy is used to store more than one dimensional objects, like we can store 2D matrices or 3D matrices which are not possible in Python using lists and tuples. It is also efficient in computation, like it uses optimized C code for its processing. As the code is in C language, it is very efficient and it is very fast and accurate. It is also foundation for the data science. It also supports operations in machine learning and in other domains as well. So why to use NumPy over lists? As we know that in Python lists are one of the data structures and it is very flexible, and it can also hold different values of same or different types under a single variable name. It is also mutable. We can access any element at any point of time when we need it. The main difference or drawback when it compared to NumPy arrays is that the memory storage. In list the memory storage will be very high when compared to NumPy arrays, or rather it is correct to say that the NumPy arrays will take very less memory storage in the database, and it also completes faster evaluations and with most of the accuracy. So general examples in Python. So by using NumPy in Python we can perform basic operations and on arrays, matrices, and it also supports element-wise arithmetic operations like addition, subtractions, multiplications, etc. And it also has advanced features which includes functions for integration, differentiation, and also for linear algebra, vector algebra, etc. So NumPy for data science, as I have already mentioned that it is very useful for the data science, or it is a foundation for the data science to go ahead. So it also helps in data processing, efficient manipulation of large data sets and matrices, and it also works seamlessly with pandas, scipy and scikit-learn. So here as we can see that to install NumPy we have to first install the pip module by using this command and to add it into our Python environment. So now let's go into the code editor and let's try few examples and understand in a better way on how to use NumPy. We are on our code editor screen, but before writing our code we have to install our Python package of NumPy into our operating system. So to do that, just click on Windows and R on the keyboard and click on OK. So here the command prompt window will be available on our screen. Now just type pip install NumPy and click on enter. So the NumPy package will be installed on our operating system, and then we can write our code using NumPy. So here as I have already installed the NumPy package, it is showing that requirement already satisfied. After completion, just close the window and now let's try to write our code. So before doing that, just we need to import the NumPy package. So let's import our NumPy package. So to make it simple, I am importing the NumPy package as np. So now let's try to take a sequence of numbers and print it on the screen. So to do that, just take a variable name, say arr, and here we need to use the syntax like np.range, which defines as the range of array, or we can also say it as array range. Here as we have written np.arrange, now we have to give the range of numbers. Let's say that we want all the single digit positive numbers to be printed on the screen. So just give the number as 10, so it will print from 0 to 10 minus 1, like 0 to 9. The numbers will be printed on the screen. Now let's write the print statement and run this code to check the output. So here, as you can see, that all the single digit numbers have been printed like in the format of an array. Let's say if you want only odd numbers to be printed from 0 to 9. Now I'm using the same variable name as ARR and using the syntax like np.arrange. I'm taking the starting value as 1. So as we all know that 1 is the odd number from 0 to 9, starting odd number from 0 to 9, and it all goes up to 10, but we know that odd number repeats for every twice, so I'm incrementing the range by +2, like after every digit it increments by 2. Now I'm just writing the print statement to check the output. So here, as you can see, all the odd numbers have been printed from 0 to 9. Now let's say if you want to create a 2D array, so I am taking the variable name again same as ARR is equal to, here we are creating an array, so we have to use syntax like np.array. Now let's say the first array or the first row, the elements in the first row are 1, 2, 3, and I am taking the elements in the second row as say 4, 5, 6, and I am just trying to check the output. See here, as you can see, 1, 2, 3 elements have been printed on the first row and 4, 5, 6 have been printed on the second row. This is an example of creating a 2D array by using NumPy in Python. Now let's say you have an array. Now let's try to perform some operations using arrays. So let's say you have an array named A having elements like 3, 7 and 5, and we are taking an array B, say np.array, which have elements like 2, 10, 8. So now let's try to perform some operations on the arrays. Now if we want to get the sum of both the arrays, we just need to write the print statement as print a plus b. Now let's try to find the output. See here, as you can see, the sum of the elements have been printed on the screen as 3 plus 2 is 5, 7 plus 10 is 17, and also 5 plus 8 is 13. The sum has been printed. Now let's say if you want to do the product of the matrices, you just need to write print a into b. Here the product will be displayed on the output screen just like this. Now let's say if you want to create an array with the given number of rows and columns you want in between 0 to, with the elements in between 0 to 1. For that we have to import a new module called time, which is used to take or give the random numbers from 0 to 1 to create our array. For this one we are just taking a variable name called as a, and I am writing the syntax like np.random.rand function. This rand function is used to create the array with the specified rows and columns. Now let's say I am giving the number of rows as 3 and number of columns as 4. So now I am writing the print statement to check the output. Here, as you can see, that the number of rows have been 3 and the number of columns have been 4, as here I have mentioned the position of rows and columns. All the numbers are between 0 and 1. So the rand function is used to take the random numbers between 0 to 1 and create an array with our requirements. So now let's say if you want to do some statistic calculations and you want to find the mean of the given data. So for that I am just taking a data, say variable name as data, and I am creating an array of say few data like 5470. I'm just using random numbers. You can also mention your data or any random numbers just to check the result. Here I have taken 5 values, and now just I want to print the mean of the data. So here I am using the function log. Here I am using the function like np dot data, np dot mean of data. So now let's check the output. So here, as we have seen, the mean of the given data is 65.4. Now if you want standard deviation of the data, so we will just erase the mean and we will write std. So by writing std, we will get the standard deviation of our given data. So here it is, the standard deviation of the given data is 21.4 and it goes on. So now let's say if you have a sequence or a 1D array of data or data in a list, now you want to convert into the 2D or into a required format like number of rows and number of columns. For that we have a function called as reshape. So here I am taking a variable as and taking a range of elements from 1 to 6. So here our elements will be from 1 to 6, which will be in a single line or in a format of list. So now I am taking another variable as b, and here I am using the reshape function. So here I will be giving the number of rows as 3 and number of columns I am giving is 2. So now I am writing the print statement to check the output. So here, as you can see, that if the only first line is executed and the print statement has been written, the output will be like 1 to 6 in a single line. But here, as we have used the reshape function, so we have given the number of rows and columns as 3 and 2. Here the number of rows are 3 and the number of columns are 2 as mentioned. So guys, by writing one last program, we will end this video. So in this program we will be calculating the product of 2D arrays, or simply we can say that multiplication of 2D arrays. For this I am taking two 2D arrays named A and B, in which I am taking elements as 1, 2 and 3, 4. In the second one I will be taking the values as 5, 8 and 6, 9, and here I am changing the name of the array as B. So in NumPy we have also one function or a feature called dot, by which we can perform the multiplication operation. So here I am taking another variable called result, and here I am using the dot function, and here I am giving the two 2D matrices. So in the next line I will be printing the result so that the multiplication will be done. See, as you can see, the product of the two 2D matrices has been done by writing a single line of code, which is very useful and which is very time efficient. So guys, this is the video. I have tried to explain some basic operations and functions which we can use by using NumPy to solve few basic and complex problems. I hope this video is very helpful, and thank you, and let's meet in our next video.